Most gardeners trying to increase earthworms are doing the exact wrong thing. They keep piling on compost, buying bottled worm boosters, or overwatering their beds thinking, moisture alone will bring worms in. What actually happens is the soil goes anaerobic, microbial diversity crashes, and worm populations stall or even decline. I've tested this in raised beds, in-ground rows, and even large grow containers. If your worm count isn't doubling during peak season, it's not because you need more organic matter, it's because you're missing one biological trigger: living water. If you care about soil that builds itself, not soil that constantly needs inputs, subscribe to the channel. This is where we focus on methods that produce measurable changes, not garden folklore. What I'm about to explain isn't about dumping stagnant water into your beds. It's about using biologically active pond water correctly, at the right dilution, at the right timing, to stimulate microbial blooms that worms respond to almost immediately. Here's what most serious gardeners don't want to admit. A bed that's rich in finished compost can still be biologically narrow. You may have bacteria, you may even have fungi. But diversity is often limited to what survived the thermophilic composting process. That means fewer protozoa, fewer microcrustaceans, and fewer free-swimming microbial species that worms feed on indirectly. When I first compared two identical raised beds, both 4 feet by 8 feet, filled with the same compost blend, I noticed something strange. The bed that was closest to a small wildlife pond always had more worms when I dug test cores. Same soil mix, same mulch, same irrigation schedule. The only difference was runoff and splash from the pond during rain. That's when I started experimenting intentionally. A healthy pond is a microbial engine. It contains aerobic bacteria, algae, fungal spores, protozoa, nematodes, and dissolved organic compounds in a constantly cycling system. When you take water from a balanced pond, not a foul, stagnant one, and apply it correctly to soil, you're not feeding worms directly. You're inoculating the soil food web. Earthworms respond to microbial blooms. They follow food density gradients. When microbial activity spikes in the top 2 to 4 inches of soil, worm casting activity increases within days. The key is source quality. A natural farm pond, a wildlife pond, or even a well-maintained ornamental pond works. I've tested water from systems similar to those managed by groups like the Pond Society guidelines, where biological filtration and plant balance keep water aerobic. Avoid chlorinated water features or chemically treated decorative ponds. If the pond smells sulfurous or like rotten eggs, don't use it. That's anaerobic and counterproductive. Straight pond water can overwhelm soil if poured heavily. I've found, honestly, the most consistent results at a 1:5 dilution. That's 1 part pond water to 5 parts non-chlorinated water. For a standard 4x8 raised bed, that works out to about 2 gallons of pond water mixed into 10 gallons total solution. You want to apply it evenly over the bed surface in the evening, when soil temperatures are between 60 and 80 degrees Fahrenheit. That temperature window really matters because microbial reproduction accelerates there. In hotter soils above 90 degrees, oxygen drops and the effect weakens. In small backyard plots, I use roughly 1 gallon of diluted solution per 10 square feet. In larger in-ground gardens, about 20 gallons covers 200 square feet. You don't drench the soil, you just moisten the top layer. Within 7 to 10 days, worm activity increases visibly under the mulch. Compost tea has its place, but most homemade versions are, biologically inconsistent. Unless you're actively monitoring dissolved oxygen and brewing under controlled conditions, you often end up with bacterial-heavy tea and minimal protozoa. Pond water already contains multi-level trophic biology. It's not brewed, it's active. It includes grazers that stimulate bacterial turnover, which in turn releases plant-available nutrients. Worms thrive in that cycle. So, I ran side-by-side tests. one bed treated with aerated compost tea brewed for 24 hours, and another with diluted pond water. After about 3 weeks, soil core samples from the pond-treated bed averaged nearly double the worm count per cubic foot. This isn't magic, it's ecosystem transfer. If you apply pond water to bare soil, well, the effect is really just temporary. UV exposure and surface drying reduce microbial survival, but under 2 to 3 inches of shredded leaves, straw, or even partially decomposed wood chips, the moisture and biology actually stabilize. In one of my hydroponic trials, yes, even there, I used pond water at a 1 to 10 dilution in a soil-based grow bed system, not in pure nutrient solution. The microbial inoculation reduced biofilm buildup and increased root zone biological activity without clogging emitters. But honestly, that only worked because the system had organic substrate and proper aeration. Worm populations in adjacent soil beds increased as runoff carried microbial life outward. Applying diluted pond water once every 3 to 4 weeks during the growing season is enough. Over-application can shift soil too bacterial and temporarily reduce fungal networks. That really matters if you're growing perennial crops. In annual vegetable beds, think tomatoes, squash, brassicas, you can apply monthly during active growth. In perennial beds, though, limit it to twice per season. Early spring application jumpstarts worm emergence. Late summer applications rebuild populations after heat stress. You don't need constant inputs, you need biological pulses. Within 48 hours, microbial respiration increases. You can measure this with a simple soil respiration test kit, but you can also, observe it through increased worm castings on the surface. By day 5, you'll notice more soil aggregation. That crumb structure forms as bacteria and fungi produce glomalin-like compounds that bind particles together. Worms then tunnel through that structure more efficiently, increasing aeration. After 3 weeks, the soil holds moisture longer. That's not because of the water you added, it's because worm channels improve infiltration and retention. In my sandy test plot, organic matter increased by nearly 0.4% over one growing season, using only mulch and pond inoculation. If your soil already drains poorly and smells sour when wet, fix drainage first. Pond inoculation in compacted clay without aeration can actually worsen anaerobic pockets. If you rely heavily on synthetic fertilizers, you need to understand this. High salt levels suppress microbial life. You can't expect pond biology to thrive in a chemically aggressive environment. Either reduce synthetic input or, honestly, don't bother. And if your pond contains fish treated with medications or algicides, just skip it. Those residues affect soil biology. In a 100 square foot backyard garden, I use 10 gallons of diluted solution once every month from April through August. I collect pond water in the morning, dilute immediately, and apply the same day. By mid-season, digging a 6-inch test hole reveals visible worm clustering near the mulch-soil interface. Before implementing this method, I averaged maybe 5 to 7 worms per spade slice. After 2 months, I consistently count 12 to 15 in the same volume. That's not theory. That's observable biology. Higher worm populations mean more castings. Worm castings contain plant-available nitrogen, phosphorus, potassium, and trace minerals in stable forms. They also contain plant growth regulators produced by microbes. You're not just increasing worm numbers, you're increasing nutrient cycling speed and soil resilience. In dry spells, beds with higher worm density maintain crop vigor longer without irrigation. That alone changes how much you rely on external inputs. You're borrowing biodiversity from a stable aquatic ecosystem and introducing it to terrestrial soil. Nature connects these systems during floods and rain events. We're simply replicating that intentionally and in controlled amounts. Most gardeners separate water systems from soil systems. That's a mistake. Integrated biology always outperforms isolated inputs. If you don't have a pond, find someone local who does. Even a healthy rain-fed pond works. Store the water no longer than 24 hours before application to preserve aerobic life. You don't need expensive amendments. You need living inputs. And if this kind of grounded, tested knowledge helps you grow better food with fewer gimmicks, subscribe to the channel and share this with another serious gardener. The more people who understand how to build soil biology instead of just buying it in bags, the better our gardens and our food will be.